Okay, we're ready for part 2 of our microcontroller application radio frequency ID tag reader demonstration. I have my Explorer 8 demonstration board wired up here with my 40-pin PIC 18F4520 that we looked at, and we looked up all the pinouts for it. On the right-hand side here is my radio frequency ID tag reader antenna. I've got 4 wires connected to the 4 pins, the red wire being power, the black wire being ground, and if we remember the color code from our setup here, green was our enable, and yellow was my actually serial uh, serial transmitter, which if we look at my little tags on here, this is labeled at RC7. So I got all my little things tagged so I know where to plug them into the board. Way up top here's push button. So there's my switch 2 push button that I can use to interface to interact with my board. That's also hooked up to port B pin 3, the blue LED. So that's the active high right now, which is disabling the reader. And for some reason, the reader is green when it's disabled and red when it is enabled. And then here's my PIC Kit 3. So this is a programmer debugger that's hooked up via USB cable back to my PC. It's got a nice little 6-pin header interface. You just plug straight in here, little flashing status light. So when I assemble and load my software, it simply downloads it onto the PIC18 board for me here. So that acts as a programmer to program the chip, but it's also a debugger. So all the interactive debugging stuff that I could do, like in the breakpoint manager on the PIC18 simulator, I can do that all live on the chip with hardware connected up in the loop, so I can actually run my software, wave my tags. Down here at the bottom, I've got 2 radio frequency ID tags. So these are just pieces of plastic. What I've got is I've got them labeled with their tag IDs. So remember our tag ID was a 10-byte ASCII printable code. So this tag is 0700B90946, and this is 65001-2B10C. Now what I did is I labeled on the colored tags here, the first byte is 6, the ASCII code for 6 is 36. The first byte here is 0, the ASCII code for 0 is 30. So it'll make it easier for me to look in the register to identify where that tag ID. So remember the format of the tag is going to be 0A as a start byte, this 10-byte ID, and then 0D as a stop byte. So those are going to be 12 bytes that are going to be stored in my table in my memory. Okay, so to look how we're going to program and debug this, let me go ahead and share my screen. And let's blow up my camera so you can see both things going on here. Okay, so this is called MP Lab. So this is Microchip's free programming and debugging software that you can get right off their website. It comes with an interface, an assembler where we can type and run code and do all that stuff. Here's all the project files I've been working on over here. So notice this is the RFID PIC18 F4520 running on the Explorer 8 board, and I've opened up RFID.asm, which is the code that we went over in the setup here. And likewise, in the code, I've gone ahead and set a breakpoint that we'll use in a minute here. So the same way I did it in the simulator, I just get a little stop sign here. I click on a line of code that says, okay, once I run the debugger, this will run live until it gets to this line of code, and then it will pause. And that will allow me to actually look inside file registers here and look at different values in the memory to see what I'm doing along the way. If I just wanted to run this thing like I ran the demos the other day, I literally come up here and do this that says make and program device. That's the equivalent of assemble and load. So let's go ahead and do that. Just assemble and load. It connects to the programmer. it says, hey, I'm going to program this, device was erased, and program verified complete. So my board is now running live over here. How do I know it's running live? Well, let's come over here and push the button. If I push the button, we can see that RB0 went out, and we can see that my LED turned red to say I'm waiting to read a tag. I wave my tag over here. The light turns green to say, hey, I read your tag. And basically, you get a nice user interaction here. Push the tag. It says I can read a new tag. I wave my tag, and it says, hey, I read your tag. But I can't really tell what the tag ID is. All I know is the lights are working. So the interaction, it must be receiving because it's going through the loop, because it wouldn't disable the reader unless it actually got a valid 12-byte code and the counter counted down. So how do I see what the tag ID is? That's where I can come up here and run the debugger. So instead of just running live like I am now, I'm going to do this. It says debug the main project. So this will assemble and load just like we did before, but it will also add code on it that allows me to interface and start and stop and pause and do breakpoints and communicate back up the USB cable to the PC. So notice it programmed, but now it says it's running. So now I have this new console that popped up here with a pause button and a stop button, so I can actually pause. So if I pause this, where would I be in my software? So remember, my software came up here and it initialized everything, and then it dropped down in this loop waiting for the user to push the button. So I should be just sitting in this loop right now. So if I pause, look, I'm sitting here in the loop right now. And if I run again, it's waiting for the user. So I can do all that live. So now that I'm running again, let's go ahead and push a button. If we look at the file registers here, we ought to be able to tell where the tag gets read. So remember, our tag table is supposed to go in here at 40. So there's a whole bunch of garbage here at 40 right now. So this is where our tag ID should show up. So we will push a button, and let's take tag 30, the first tag here. Take tag 30 and wave tag 30, and then we pause and we hit the breakpoint, and then we can run and we can tag and we can read the other tag. Okay, so how do we tell if you watched the 40, the tag ID down here start changing? We see the tag got read in here as 0A3635. So that's 6500. Oh yeah, I can read it over here. 650012B10C. As we see, that's the purple tag. Let's go ahead and try to read the green tag. So, oops, I got to run here. So run, push the button, read the green tag. And now if we look down in our table here, things in red are the things that changed. So notice 0A and 0D stayed the same, but notice my first tag byte now is 30, and we can read our tag here is 0700 B90946. There we go. So that's my tag ID that I got here. So let's read the purple tag one more time here. Run button, purple tag, and then we can see it shows up in the table 605. So I've got a nice live interactive project running here where I can run the software live, I can run the debugger, I can add and stop breakpoints, I can actually peek into memory values. If I wanted to look at other special function registers or anything else, I can actually tag different register values themselves as variables and look at them and track them to see what's stored in certain places. I'm just simply looking at the file registers right now, the general purpose registers, and my table at 40. So now here we have a completely interactive hardware software setup using our PIC18 4520 chip plugged into an Explorer 8 demonstration board with interaction from a push button switch and some LEDs. and then the wires from the ports going to my hardware radio frequency ID tag reader over here, and then all communicating back and forth to the PIC8T through my PIC Kit 3. And so I can run my software, debug my hardware all interactively, just like I could do in the simulator, but now I actually have hardware in the loop. Okay, all for today. I think the next thing on the agenda is gonna be doing the review.